So, dear students, this is part 3 of calendars and dates trick that we are discussing. And in this part, we are going to learn how we can find day of the week for any random date. For example, if somebody asks you which day of the week was it on 3rd June, let's say 1664. So a random date, completely random. So without referring to calendar, without referring to any mobile device, so how we can actually mathematically tackle these type of questions, so that we are going to learn in this video. So let's begin now. So before we proceed further, we have to understand a very important fact. A non-leap year. So if the year is not a leap year, that means it is a normal year. So a normal year has 365 days. So if you calculate 365 days, so 365 days is actually equal to 52 weeks plus one extra day. So what does this mean? Suppose we take the year 1999. So 1999 is not a leap year, so we call it a non-leap year. So since it is a non-leap year, it will have 365 days. Now, what is the real hidden, you can say, the fact that you have to understand here? So 365 equal to 52 complete weeks. So from here to here, 52 complete weeks plus one extra day. So extra day is all that matters in determining the correct answer. Now, what is the actual meaning of this? So suppose 1st January, 1st January of the year 1999, let's suppose that it was Friday. So let's suppose 1st January of the year 1999 was Friday. So what can you determine if you understand that this year had one extra day? So if this year had one extra day, it means even if you remove all these complete weeks, one extra day remains, and that one extra day would be what? It would be Friday. So this basically means that the last day of that year, that means you can definitely be sure that 31st December of the same year 1999 was Friday. So if you understand how many extra days are generated per year, then you can, without going for lengthy calculation, you can immediately predict or determine with surety which day of the week is a random date falling on. Now coming to a leap year, we know that leap year has got one more day as compared to any normal year. So normal year have got 365 days. Therefore a leap year has got one extra day. That means 366 days. And this one extra day makes, if you calculate properly, then 366 days is equivalent to 52 weeks plus 2 extra days. So in case of a normal year generates one extra day, whereas a leap year generates two extra day. You have to remember this. So the year 1999 generated one extra day because it is a normal year. The next year, that is 2000 AD. So 2000 AD is a leap year, and any leap year generates two extra days. So this is the fact that you would need to remember to solve the remaining pattern of questions. Simple fact, normal year generates one extra day and a leap year generates two extra days. Now in the last video lecture, we discussed what are the rules to determine leap year. Anyways, let me help you recall it. So suppose you are given any year, a particular year is mentioned. It may be 1884, it may be 1600 AD, it may be 1930 AD. So if I give a year to you and I ask you to determine whether it is a leap year or not. So how do you do that? So we pick the last two digits of that given year. So last two digits. We pick last two digits. So from here, if 1273 AD is given, then we will pick the last two digits, that is 73. In case, if the last two digits are 00, for example, here you see 1300 AD, the last two digits are 0, then we don't pick 00s. Picking 00 is not allowed. So then we have to pick the first two digits. So there is an exception. If the last two digits are 00, then don't pick 00. Pick the first two digits instead. So here we picked 73. So from 1273 AD we picked 73. Last two digits. But when we try to do the same on 1300 AD, we cannot pick 00. Therefore now we are picking 13. So what do we do after picking two digits? So we have picked two digits, divide those two digits by 4. So from 1273 AD we have picked 73 and from 1300 AD we have picked 13. So if you want to understand whether 1273 AD is leap or not, so you have picked the last two digits 73. Now divide 73 by 4. And if it is perfectly divisible, is it divisible? You have to ask this. Is it divisible? So it is not divisible. If the answer is no, that means the given year 1273 is not a leap year. Fine. So now let's take 1220 AD. So 1220 AD. I pick the last two digits. So 20. So if I divide 20 by 4, it is divisible. Yes, it is divisible. So if the answer is yes, then I would say that 1220 AD is a leap year. Now, what is the exception? If the last two digits are 0, then you pick the first two digits. Now see the impact of this. 100 AD. 100 AD is not leap. It is a non-leap year. Why? Because you cannot pick last two digits. So you will divide 1 by 4. So the testing, divisibility test will be done on 1. So 1 is not divisible by 4. Therefore, it is not a leap year. Similarly, 200 AD. You cannot pick this 00. So you will do the divisibility test on 2. So you will try to understand, is 2 divisible by 4? Answer is no. So this is not a leap year. Similarly, 300 is also not a leap year. 400 AD. You cannot pick these two zeros. The first or the remaining digit is 4. So you do the divisibility test on 4. Is 4 divisible by 4? Of course, yes. So therefore, this is a leap year. So please understand, these are exceptional cases. 500 AD is not a leap year. 600 AD is not a leap year. 700 AD is not a leap year. But 800 AD is a leap year. Similarly, 1200 AD, 1600 AD, 2000 AD, 2400 AD, all these are leap years. And the remaining ones that you are looking at your screen are not. Because of the rule to determine which years are leap and which years are not leap. So before we begin solving questions, these are the three key facts that you have to understand. A normal year generates one extra day. Normal year generates one extra day. A leap year generates two extra days. So 100 AD, 200 AD, 300 AD, all these are not leap years. Though 100 is divisible by 4, so normally it looks like that this must be a leap year, but no. The rule says that if last two digits are 0, the divisibility test have to be done on the remaining digits. Therefore, please understand which ones of these are leap and which ones are not. Now let's move forward. Now see, the modern calendar that we are using. So modern calendar has got 12 months, January to December. So how many days are there in each month? It is fixed. January has got 31 days. February will have either 28 days or 29 days. 28 days if it is a non-leap year, 29 days if it is a leap year. Similarly, number of days for each month is fixed. Only you have to be bothered about month of February, whether it is a leap year or not a leap year. So this is the modern calendar that we use in our everyday life. Now, when the modern calendar was designed, the modern calendar was designed, so the first day of the modern calendar was assumed, or you can say was given the date 1st January 1st AD. So you can say the counting of calendar began from 1st of January 1 AD. There is nothing called as 0 AD. 0 AD does not exist. The year 0 does not exist. So the counting began from 1st AD, then after 1 year came 2 AD, then after 1 year again came 3 AD and so on. So 0 AD does not exist in human history. The calendar began on 1st January 1st of AD. Now 1st January 1st of AD, the first day of the calendar was assigned as a Monday, not as a Sunday but as a Monday. So you can say the first week of human history or modern calendar history, the first week of modern calendar begins from Monday, or the week of a modern calendar begins from Monday, not from Sunday. It begins from Monday and the week ends on a Sunday. So you work and then you enjoy. The week does not begin on Sunday. So you have to keep all these things in mind. So 1st January 1st AD is the first date assigned when the calendar started counting, or when the calendar came into operation. And that day was given Monday. Now let us understand how many days were there in the year 6 AD. So you have to ask, is 6 AD a leap year or is it a normal year? So 6 is not divisible by 4. So it is a normal year. It is not a leap year. It is a normal year, and a normal year has 365 days. Now, how many days were there in the year 1216 AD? So 1216 AD, whether it is leap or whether it is normal, how can we decide? Pick the last two digit. So here I can pick the last two digit, because the only exception is that I cannot pick 00, but there is no 00 here. There is 16, so I can pick 16. Now divide 16 by 4 and ask yourself, is it divisible? Is it divisible? Answer is yes, it is divisible. So answer is yes, this is a leap year. So therefore 1216 AD is a leap year, and a leap year has got 366 days. So this is the answer. Now this is very interesting. Which day of the week was it on 1st January 12 AD? Now what information do we already know? 1st January of 1st AD. This is Monday. The calendar began counting on this date. Now you have to determine which day of the week is it on 1st January of 12 AD. Now let's do the counting. 1st January of 12 AD. 1st January of 12 AD means what? 11 complete years. 11 complete years. How 11 complete years? From 1 AD to 11 AD. So 11 complete years plus the next day. The next day is 1st January of 12 AD. So this is the total date that is given to you. You know that 1st January 1st AD is Monday. That means the modern calendar is designed in such a way that the week begins from Monday. Week begins from Monday and ends on Sunday. This is how our modern calendar is designed. Now 11 complete years. So we have just studied that a normal year generates one extra day and a leap year generates 2 extra days. Now we have to put this fact to use here. So in these 11 years, there are only 2 leap years. Only 2 leap years. Which ones? 4 AD and 8 AD. So there are 2 leap years and 9 normal years. 9 normal years. So from here, how many extra days were there? You have to focus only on extra days. So 2 leap year. So 2 into 2, because one leap year generates 2 extra days. So 2 into 2. 9 normal year. Each normal year generates 1 extra day. So from here you can see that 2 into 2 is 4. 4 plus 9 is 13. So from here 13 extra days, and next day you have taken one more day. So 13 plus 1, 14. So 14 days. Now 14 days means what? 14 is completely divisible by 7. 14 days means 2 weeks. 2 weeks. So as per our calculation, there are no extra days. 0 extra day. So 0 extra day means what should be our answer? Day number 0. So what is day number 0? Day number 1 is Monday, because the modern calendar is designed in such a way that the week begins from Monday. So day number 1 is Monday, and what we have solved is telling us that there are 0 extra days. So 0 extra days means answer is day number 0. So day number 1 is Monday. So 0 comes just before 1. So what comes just before Monday? Sunday comes just before Monday. So answer is Sunday. Let's solve this one. Which day of the week was it on 15th March 63 AD? 15th March 63 AD. So what do you know? You know that 1st January of 1st AD is Monday, and this is the day calendar began. You have to find out which day of the week was it on 15th March 63 AD. So what should your calculation be? So 15th March 63 AD. So to reach there, first 62 complete years have gone by. 62 complete years. Because 63 AD is still running. It is still going on. Then month of January, because it is 15th March. So first entire January is gone. Then entire February is gone. And then some days from March. Some days from March. So this is what you have to count. So counting starts from 1st January 1st of AD and counting stops on 15th March 63 AD. So in these 62 years, how many leap years would be there? So divide 62 by 4, you will see that 15 is the quotient. 15 times division takes place. So 15 leap years. And obviously the remaining 47 are normal years. Then came January of 63 AD. So 63 AD January has 31 days. Then came February of same year. So 63 AD is a normal year. So February will have only 28 days. And March, you have taken 15 days from March. So now you have to focus on extra days. Extra days. So 15 leap year. One leap year generates 2 extra days. So 15 into 2 plus 47 normal years. So one normal year generates one extra day. So 47 into 1. So from here 30 plus 47, 77. 77 days. Now incidentally 77 is divisible by 7. That is equal to 11 weeks. So it is divisible by 7. So there is nothing extra here. So you can remove this completely. We have to focus only on extra days. That means whatever is left after getting divided by 7. So 77 is completely divisible by 7. Nothing is left. So there is nothing extra here. Now January 31 days. So divide 31 by 7. What is the remainder? Remainder is 3. So 3 extra days from here. Divide 28 by 7. So 28 is completely divisible by 7. 0 extra days. Divide 15 by 7. 1 is the remainder. So 1 extra days. So final answer is 4 extra days. So day number 4. Whatever is day number 4 is our answer. So modern calendar, our calendar began on Monday, and we have to find out what was day number 4. So day number 1 was Monday, Tuesday, Wednesday, so Thursday. So day number 4 is Thursday. So you can pause this video, rewind it, have a look at it again. Next question, which day of the week was it on 3rd June 81 AD? 3rd June 81 AD. So counting must start from 1st January 1 AD and counting will stop on 3rd June of 81 AD. So it means 80 complete years, 80 complete years, and 81st year is still going on. So January of that year, February of that year, March of that year, April of that year, May, entire May of that year, and then some days from June. So now let's complete this calculation. So in 80 years there are 20 leap years and remaining 60 are normal. January has 31 days. 81 AD is not a leap year, therefore February will have 28 days, March 31, April 30, May again 31, June you have taken only 3 days from June. Now let's focus on extra days. So 20 leap year, each leap year generates 2 extra days. So 20 into 2 plus 60 normal year, each normal year generates 1 extra day. So 60 into 1. So 20 into 2, 40, 100 days. So you can further divide this 100 by 7. Divide 100 by 7, 2 will be the remainder. So 2 extra days. So ultimately 2 extra days from here. Now divide 31 by 7. You will realize that 3 extra days. So 2 extra day already plus 3. 28 is completely divisible by 7. So 0 extra days. From March again 3 extra days. From April 2 extra days. From May 3 extra days from May. And from June you have taken 3 days. So 3 extra days from June as well. Now let's count. 2 plus 3 5. 5 plus 3 8. 8 plus 2 10. 10 plus 3 13. 13 plus 3 16. 16 days. But we have to focus only on extra days. So 16 can also be divided by 7. So if you divide 16 by 7, 2 is the remainder. So 2 extra days. Our job is only to find extra days. How many extra days? So 2 extra days. So final answer 2 extra days. So our modern calendar began on Monday. So first day is Monday, second day is Tuesday. So our answer is Tuesday. Now let's solve this. How many leap years were there in the first 30 years of modern calendar? So in first 30 years, so first 30 years means between 1 AD to 30 AD. First 30 years of human calendar. So how many leap years were there? So leap year generally occurs after every 4 years. After every 4 years, but you have to be careful. 100 AD is not a leap year. 96 AD is a leap year. After 4 years comes 100 AD, but we cannot consider 100 AD to be leap because of last two digit is 0 and 1 is not divisible by 4. So you have to be careful with such kind of dates. But here the given range is first AD to 38 AD. So which are the leap years? 4 AD, 8 AD, 12, 16. So basically multiples of 4. So how many multiples of 4 are there? So only these are the multiples of 4. So let's count them: 1, 2, 3, 4, 5, 6, 7. So between 1 to 30, there are 7 multiples of 4. 7 4s are 28. And this is the closest you can come to 30. So 7 multiples of 4 are there. Therefore 7 leap years. So the answer for this one is 7 leap years. So there are 7 leap years in first 30 years. 7 leap years. Now second part. How many odd days? How many odd days got accumulated in first 30 years? So we just calculated that in first 30 years, there are 7 leap years. 7 are leap. That means remaining are normal. So how many are remaining? 30 minus 7. Out of 30, 7 are leap. So remaining 30 minus 7, 21. So 21 are normal. So how many extra days will get generated? One leap year generates 2 extra days. So 7 into 2, 14 extra days. And one normal year generates 1 extra day. So 21 into 1 is 21. So 14 plus 21 is equal to how much? So that is equal to 35. 35 extra days. So out of 35 extra days, you have to further divide this by 7. So 35 divisible by 7. So 35 is completely divisible by 7. So I would say no extra day or 0 extra days. 0 extra days. Now this question, how many leap years? How many leap years are there in first 100 years of modern calendar? So between 1 AD to 100 AD. Between 1 AD to 100 AD, how many leap years are there? So leap years are basically multiples of 4, but there is one exception. So 4 AD, 8 AD, 12 AD. So basically multiples of 4. So if you continue this way, 88 AD, 92 AD, 96 AD. But we cannot consider 100 AD as leap year. 100 is also a multiple of 4. But we cannot consider 100 AD as a leap year because last two digits are 0. So if you pick 1 and try to divide it by 4, so 1 is not divisible by 4. So 100 AD cannot be considered as a leap year. So from here to here, there are only 24 multiples of 4. So 24 multiples of 4 can be counted. So therefore, 24 leap years are there in first 100 year of calendar's history. 24 leap years. Fine, and not 25 because 100 AD cannot be considered. So only 24 leap years. So the second part is that in these first 100 years, so in first 100 years, there are 24 leap years and the remaining, that means 100 minus 24. So 76 years are normal years. So in the first 100 years, how many extra days or odd days got accumulated? So one leap year generates 2 extra days and one normal year generates 1 extra days. So 24 leap year would generate 48 extra days, 24 into 2. And one normal year generates 1 extra days. So 76 into 1 is 76. So if you add these up, it comes out to be equal to 134. Sorry, 124. 124 days. So this can be further divided by 7. So let's divide 124 by 7. So what do we get? Remainder. So let's, if you solve this, let's see what is the remainder. So 7, you subtract 54, so you can subtract 49. So 5 is the remainder. So ultimate or final remainder is 5. So you can say 5 extra days or 5 odd days get accumulated in first 100 years. So in first 100 years, 5 odd days get accumulated. And in first 100 years, there are 24 leap years. Now, question is, how many odd days were there in first 100 year of modern calendar? So we just solve this. 5 odd days. 5 odd days, we just solve this. Which day of the week was it on 3rd January 102 AD? Now, what is the meaning of this question? Which day of the week was it on 3rd January 102 AD? We know that our calendar began on 1st January 1 AD and it was a Monday. So you have to start counting from here, and counting must stop on 3rd January 102 AD. We also know that in first 100 years, 5 extra days get accumulated. So if you take the total account, so first 100 years have completely gone by. Then 101 AD, 101 AD, and then 3rd January. That means 3 more days. 3 more days from January, month of January of next year. That means January of 102 AD. So this is the total count. So in first 100 years, we have already found out that 5 odd days get generated. This you have to remember. This you cannot solve again and again because this will require time, and this is a fact. So it's better if you remember that in first 100 years, 5 extra days get accumulated. So we are only interested in extra days. So we already know that in first 100 year, 5 extra days get generated. So we write 5 here in 101 AD. So this is a normal year. This is not a leap year. So a normal year generates 1 extra day. And from 102 AD, we are picking only 3 days. So 3 here. So we are interested only in extra. So let's add this 5 plus 1, 6, 6 plus 1, 9. So 9. So this 9 can also still be divided by 7. So if you divide 9 by 7, remainder is 2. So 2 odd days. So 2 odd days means day number 2. So our calendar, modern calendar, began on a Monday. And answer is 2 odd days. So first day is Monday. Second day is Tuesday. So answer is Tuesday. So 3rd January 102 AD definitely was a Tuesday. So how many leap years were there in first 200 years? So see, 1 AD to 100 AD, there are 24 leap years and 5 odd days get accumulated. So if you continue this trend, that means from 101 AD up till 200 AD. Now 200 AD cannot be also considered a leap year. 200 is a multiple of 4. But same problem, you cannot pick this 00, so you will ultimately do the divisibility test and on 2 and 4. So 200 AD is not a leap year. So same logic, here again 24 leap years are there. And in this duration, that means from 101 AD to 200 AD, again 5 odd days get accumulated. So if somebody asks how many total odd days get accumulated in first 200 years, so in first 200 years, that means from here to here, 5 plus 5, so total 10 odd days get accumulated. So 10 can still be divided by 7, remainder would be 3, so 3 odd days. Now you have to do the same for first 300 years. So same pattern continues, 1 AD to 100 AD, then from 101 AD to 200 AD, and then from 201 AD to 300 AD. Same story, because 100 AD, 200 AD and 300 AD, none of them can be considered a leap year. So these, they are not leap years. 100 AD, 200 AD, 300 AD, they are not leap. So for each of them, there are 24 leap years, and in this time duration 5 odd days get accumulated. So same story for all three, 24 leap years and 5 odd days, same story. So here also 24 leap years and 5 odd days. So if you take the total, that means in first 300 years, how many odd days are there? So first 300 years, so 5 plus 5 plus 5, 15. So 15 odd days. So 15 can still be divided by 7. So if you divide 15 by 7, remainder is 1. So 1 odd day. Now let's see here. This is very interesting. So how many leap years were there in first 400 years? Now this time it is something different. 1 AD to 100 AD, then 101 AD to 200 AD, then 201 AD to 300 AD, and then 301 AD to 400 AD. So we have to understand the complete picture of first 400 years. So from here to here there are 24 leap years and 5 extra days, 5 odd days. Same story here, 24 and 5, 24 and 5. Same story here, 24 and 5. But now there is a slight change. 400 AD is a leap year. 400 AD. Even if you remove this last two zeros, so 4 is divisible by 4, so 400 AD is a leap year. So this time, in this time duration, there are not 24 but 25 leap years, and because of one extra leap year, one extra day is also there. So 25 and 6 extra days are there in this time duration. So if you take the total picture, that how many extra days are there in first 400 years, so answer is 5 plus 5 plus 5. But in the last 100 years there is one extra leap year, and because of that extra leap year there is also one extra odd day. So 5 plus 5 plus 5, but the last one is 6. So 15 plus 6, 21 odd days. So 21 can still be divided by 7. So if you divide 21 by 7, remainder is 0. So 0 odd day. So this is very important fact for you to remember, that after every 400 years, after every 400 years, there are no extra days. So in first 400 years, there was zero extra days. So very important fact. So before we move further, you have to understand this table, the significance of this table. So in first 100 years of calendar, 5 extra days were generated. In first 200 years of calendar, total 5 plus 5, that means 10. If you divide 10 by 7, final remainder is 3. So 3 extra days were generated. So between 1 AD, between 1 AD to 200 AD, 3 extra days were generated in total. And we are interested only in extra days. So it is good if you remember this, then so lengthy calculation can be saved. Similarly, between 1 AD to 300 AD, one extra day was there. So in first 100 years, 5 extra days. In first 200 years, 3 extra days. And in first 300 years, 1 extra day. But very interesting that in first 400 years, everything becomes balanced. 0 extra days. That means after every 400 years, after every 400 years, things gets balanced. So it means between 1 AD, between 1 AD to 16 AD, so 1 to 4 AD, things got balanced, 0 extra day. 400 years, again same thing happened from 5 AD to 8 AD, same thing 400 years, again 0 extra days. So if somebody will ask that how many extra days are between 1 AD to 16 AD, you will say, oh, this is completely divisible by 400 years. So this is a multiple of 400 years. So every 400 years you can take out, because things get balanced, it becomes 0. So you can remove that portion. So if somebody will ask how many extra days were there between 1st January 1 AD to, let's say, 3rd January 1603 AD. So what I am trying to say is that from 1 AD to 16 AD, you can remove from counting, because this is a multiple of 400 years, and after every 400 years things get balanced. So when balance means 0 extra days, so if any number of extra days becomes 0, you can remove that portion, because that is why we were removing one complete week. So here you can remove entire time duration of 400 years, you can easily remove. Why? Because after every 400 years, the number of extra days accumulated actually becomes 0. So by using this fact, we can answer these kind of questions. So we will try to answer these kind of questions now. Any random date will be given to us, any random date, and we will be asked to find the day of the week. So let's solve this now. So now before we attempt this question, let me reiterate that it is very important for us to remember this table. So in first 100 years, total number of extra days that get accumulated is equal to 5. Similarly, in first 200 years, 5 plus 5, 10, 10 divided by 7, 3. So 3 extra days. In first 300 years, 1 extra day. In first 400 year, everything gets balanced, becomes 0. So you can remove chunks of 400 year from the given date. So now let's solve this. Which day of the week was it on 27th August 1776? The meaning of the question is that we have to start counting from day 1 of the calendar. So day 1 of the calendar is 1st January 1 AD, and we know that this is Monday. So we have to start counting from here, and we have to stop at 27th August 1776. So what here we can do to save time is that we know that after every 400 years, after every 400 years, things get balanced out. So you can remove multiples of 400 years from here. So if you see properly, so this can be broken into 1600 years plus 175 more years, 175 more years plus the year 1776 is still going on. So 1776 partially, partially, because that year is still going on. So 1600, why I have written separately? Because this is a multiple of 400. It is a multiple of 400, and this I can easily remove. This is supposed to be removed because after every 400 year it becomes 0. So 0 means no extra day. So if there is no extra day, you can easily remove that. Your answer will not be affected. So I have to remove all this. I don't have to do calculation for all this. So my answer basically depends on this. So this is the deciding factor. So deciding factor is 175 years plus 70, the year which is partially going on. So we have to solve only this much. So let us see this now. So we have removed 1600 years because 1600 was a multiple of 400 years. So now the remaining portion is 175 more years. Why 175? Because 1600 plus 175 means 1775 AD completed, because the running year is 1776 AD. So from 1 AD to 175 AD is already gone, and 776 AD is going on, still going on. So now we have removed 1600 years, and this is what we have to calculate and find out the extra days. Remember, we are interested only in extra days. So 175 years. This you can break in 100 years plus 75 years. Let's solve this portion. 100 years. So first 100 years. So first 100 years generate 5 extra days. So you already have to remember all these things. So 5 extra days will be generated from here. These 75 years, some are leap and some are normal. So 75 divided by 4. So 18 fours are 72. So 18 are leap years. So 18 years are leap. So it means the remaining 67 years are normal. Sorry, 57. 57 years are normal. So let's take the total count of leap year from here. So one leap year generates 2 extra days. So 18 into 2, 36. One normal year generates 1 extra day. So 57 into 1 is 57. So 57 plus 36. So 93. So 93 extra days. So 5 plus 93 is equal to 98 extra days. So 98 extra or odd days. So 98 can still be divided by 7. And you realize that 98 is completely divisible by 7. 14 sevens are 19. So 0 extra days. So 0 extra days from this portion. 0 extra days. So you don't have to worry at all about this portion. 0 extra days. So whatever answer will come actually from this portion, because we are worried only in extra days. So 776 AD is still going on. Please understand, 776 AD. 76 is divisible by 4. So this is a leap year. This is a leap year. So our answer is hidden in this portion only, because everything else becomes 0. So 776 is still going on. So January, month of January has already gone. Month of February has also gone. March gone, April gone, May also gone, June, July, and some days from August. So our answer will be coming from this portion only. Rest everything has already become 0. So January has 31 days. February will have 39 days because, sorry, 29 days because it is a leap year. So 29. March 31, April 30, May 31, June 30, July 31, and August you have to take only 27 days because your counting stops on 27. Now we are worried only on extra days. So divide 31 by 7. So remainder is 3. Divide 29 by 7. Remainder is 1. From here 3. 2 from April. 3 again from May. 2 again from June. 2 extra days. 3 from July. And divide 27 by 7, you will get 6 as remainder. So 6 extra days from August. So let's add them up now. So 3 plus 1 4, 4 plus 3 7. So as soon as it becomes multiple of 7, you can remove that portion, because being multiple of 7 means being completely divisible, means no extra days. So no extra days portion can be removed. Now let's count the remaining. So 2 plus 3 5, 5 plus 2 7. It becomes 7 again, so I remove this. Now final 6 plus 3 9. 9 odd days. So 9 can still be divided by 7. So 9, if you divide 9 by 7, you get 2. 2 odd days. So 2 odd days means second day of our modern calendar. So first day is Monday. So second day is Tuesday. So let us verify if we have calculated correctly. 27th August 1776. So 27th August 1776. This is the cutting of the newspaper. This is of the actual newspaper. You can see it was a Tuesday. 27th August 1776. So you can rewind this, have a look at this problem once again. So we will take a couple of more examples. So which day of the week was it on 1st January 2021? 1st January 2021. So you have to start counting from 1st January 1st AD, and you have to stop counting at 1st January 2021. Now understand something. 1st January 2021 you have to stop counting. It means what? It means 2020 complete years have gone by, because 2021 is still going on. It is still going on. So till now, as per modern calendar, 2020 complete years have gone by. 2020 complete years have gone by. And one day, you have chosen one more day for counting from the year 2021. This is the total counting you have to do. Now, out of 2020 complete years, you can think of it as this is 2000 plus 20. 2020 means what? 2000 plus 20. So this 2000 is a multiple of 400. It is a multiple of 400. And multiple of 400 have to be removed, because after every 400 number of extra days becomes 0. So multiple of 400 can be removed. So this thing can be removed. So your answer will be hidden, or you can say will be determined from the remaining portion. 20 years, 20 years plus one more day of the decade 2021. So let's solve only the remaining portion. Now 2000 year, first 2020 years I have broken into 2000 year plus 20 years. Why? Because 2000 is a multiple of 400 and I can remove it easily. So I remove this. So answer will be determined only from the remaining 20 years plus one more day from the running year, current year 2021. Only one day have gone by, because your counting stops on 1st January itself. Only one day. So 20 years, how many of it are leap and how many of it are normal? So 20 years will have 5 leap years and remaining 15 are normal. So from here, if because our focus should be only on counting extra days, extra days. We don't have to count total number of days. So one leap year generates 2 extra days. So 5 into 2 10. One normal year generates 1 extra year. So 15 into 1 15. So 15 plus 10 25. So if you divide 25 by 7, remainder is 4. So 4 extra days or 4 odd days from this portion and 1 day from the current year 2021. So 4 plus 1 extra day. So final answer is 5 odd days. 5 odd days, that means fifth day of the modern calendar. So modern calendar started on Monday. So Monday, Tuesday, Wednesday, Thursday. So answer should be Friday. Let's verify. 1st January 2021. Was it a Friday? So this is the calendar of January 2021. So yes, 1st January 2021 was actually a Friday. Let's take one more example. Which day, what day of the week was it on 10th March 2020? So please pay attention on the given date, 10th March 2020. So that means till now, 2019 years have gone by completely. 2019 complete years have gone by. You are still counting 10th March 2020. That means 2020 year is still running. So January of 2020, you have to count. February of 2020 has also gone by. You have to count that as well. And only up till 10th March. So from March, you have taken only 10 days. So this is the total counting you have to do to reach the final answer. So from January, 31 days, and the year 2020 is a leap year. So leap year February will have 29 days. Now what will you do about the first 2019 years? So this 2019 can be written this way: 2000 plus 19 years. Why 2000? Why not 1800? Why not 1500? Because 2000 is a multiple of 400. It is a multiple of 400 and multiples of 400 can be removed without affecting the answer. Therefore, let's choose the biggest possible multiple of 400. So 2000 can be removed. It will not have any effect on answer. So we are bothered only about extra days, and we already know that 2000 is a multiple of 400, and multiples of 400 give no extra days. So why to calculate? Why to waste time? So remove that entirely. So 19 years. Let's first calculate how many extra days do we get from here. So 19 years will have 4 leap year and remaining 15 are normal. So 4 leap and remaining 15 are normal. So we know that one leap year produces 2 odd days. So 4 into 2, 8 odd days, and one normal year produces 1 extra day. So 15 plus 8 is 23, and 23 can still be divided by 7. So if you divide 23 by 7, you get 2 as remainder, and 2 cannot be further divided by 7. So finally 2 odd days from this portion. So from this portion 2 odd days. So 2 odd days already. Now let's we have already calculated this portion. Now let's concentrate from the remaining part. So 31 divided by 7. So remainder is 3. So 3 odd days from January. 29 divided by 7. Remainder is 1. So 1 odd day from February. You have taken 10 days from March. So 10 divided by 7, 3. So 3 odd days from March. So let's count them all. So 2 plus 3, 5. 5 plus 1, 6. 6 plus 3, 9. So 9 odd days. So 9 can still be divided by 7. So if you divide 9 by 7, you get 2 odd days. So 2 odd days means second day of our modern calendar. So our modern calendar began on Monday. So Monday and second day is Tuesday. So answer must be Tuesday. So let's verify whether actually 10th March 2020 was a Tuesday. So 10th March. So this is the calendar of March 2020. So where is 10th March? So here 10th March. So yes, 10th March was a Tuesday. Now let's solve one more. So which day of the week was it on 15th April 1912? So before we solve this, do you know the significance of this date? 15th April 1912. So actually Titanic, the you can say the largest ship of its times. It was very new. So Titanic sank, almost like 3,000 people sank in Atlantic Ocean. So that was on 15th April 1912. So can we calculate which day of the week was this on unfortunate day? So let's do that. So concentrate on the date. The date is 15th April 1912. So it means before this 1911 complete years have gone by. Complete years. Because 1912 is still running and 1912 is a leap year. It is still running. Your counting has to stop on 15th April. So January of running year, February, March, and 15 days of April you have to count of running year. Running year is 1912, which is a leap year. So if 1912 is a leap year, February will have 29 days, January will have 31 days, March will also have 31 days, April will have 30 days. Now what are we going to do about the first 1911 years? So we have to break it intelligently. So 1911 can be broken as 1600 plus 300 plus 11. Why? Because we already know the answer for this portion, 1600. It is a multiple of 400. So you can remove this. You already know answer for this. You also know the answer for this. First 300 year produces one extra day. So there is no need to count for these type of portion. That's why you have to break it intelligently. So 1600 years can be removed totally. 300 years produce one extra day. So one extra day. Now 11 years. 11 years means how many? 2 leap years and remaining 9 normal years. 11 years. So 2 leap years. 2 into 2 4. 9 into 1 9. So 9 plus 4 13. So 13 if you divide by 7 you get 6. So 6 extra day from here. So this portion you have already managed to calculate the total extra days. And what does it come out to be? Look here. 1 plus 6, that is equal to 7. So if you divide 7 by 7, remainder is 0. So 0 odd days or 0 extra days. So 0 extra days, that means you don't have to worry at all. So remove this portion. So from January, how many extra days are we getting? Divide 31 by 7. So 3 extra days. Similarly, 29 divided by 7, 1 extra day. March. 31 divided by 7, 3 is the remainder. So 3 extra days. April. So from April, you don't have to take 30 days. You have to take only 15 days. Because your counting has to stop on 15. So 15 divided by 7. So remainder is 1. So let's see. Let's count. 3 plus 1 4, 4 plus 3 7. So as soon as it reaches 7 you have to remove that. So only one extra day, one odd day. That means first day of calendar. So first day of calendar is Monday. So let's verify. So you can see this is the newspaper of that day, 15th April 1912. So evening edition. because the ship sank early in the morning. So in the evening, this newspaper was printed on same day, 15th April 1912. So let's solve one last one. Which day of the week was it on 15th August 1947? So 1947, 15th August, your counting has to stop. That means till now, 1946 complete years have gone by. Complete years have gone by. And the year 1947 is currently running. That should be our mathematics. So January, Feb, March, April, May, June, July, and 15 days from August. And 1947 is a normal year. It is not a leap year. So February will have 28 days, January 31, March 31, April 30, May 31, June 30, July 31. Now what should we do about 1946 years? So 1946 you have to break intelligently. So 1600 plus 300 plus 46, because we already know the answers to this question. 1600 is a multiple of 400, so this can be removed without any problem. 300 years produce one extra day plus one, so one extra day. So we already know the answer of this portion, one extra day. So we have to only solve this. 46 years. So in 46 years, how many leap years are there? So divide 46 by 4. So 11 fours are 44. So 11 leap, that means remaining 35 are normal. So 11 into 2, 22, and 35 into 1, 35. So this becomes 57. So if you divide 57 by 7, remainder is 1. So you have solved this total portion. So 1 plus 1, 2 odd days. So 2 odd days you have solved from this portion. Let's solve the remaining one. So if you divide 31 by 7, 3 extra days from January, February 28 is divisible by 7, so 0 extra days from February, from March 3, from April 2, from May 3, from June 2, from July again 3, and August 15 days are there. So divide 15 by 7, 1 is the remainder. So now let's count. 2 plus 3 5, 5 plus 3 8, 8 plus 2 10, 10 plus 3 13, 13 plus 2 15, 15 plus 3 18, 18 plus 1 19. So 19 extra days. So 19 can still be divided by 7. So if you divide by 7, 5 is the remainder. So 5 odd days. So it means day number 5 of our modern calendar. So our calendar begins from Monday. So Monday, Tuesday, Wednesday, Thursday, Friday. So Friday should be our answer. So let us verify. 15th August 1947, you know, very historic date. India gained independence on that day. So let's see if some newspapers are available. 15th August 1947, was it a Friday? So 15th August 1947, yes, it was a Friday. So the newspaper of that historic day.